Hello, good day! Ito nga pala ang inyong Sir Jello at meron ako ulit ituturo sa inyo na math video topics. Pero bago yan, huwag niyo munang kalimutang mag-subscribe sa aking YouTube channel na Sir Jello para maging updated kayo sa lahat ng videos na i-upload ko. Hello, good day! So we are now with the third and fourth type of variation. So we have the third one, which is the joint and combined variation. So on our previous videos, I already discussed to you about direct and inverse variation. So let's start off with joint variation. So when you say joint variation, so y varies directly to two or more quantities. That is denoted by y is equal to kxz. In symbol, so we can see here y over xz is equal to k, or y is equal to kxz, where k is the constant of variation. So we are talking about two or more quantities here, x and z. So let's have our example here. So we're going to find first an equation of variation where a varies jointly as b and c, and a is equal to 24 when b is equal to 2 and c is equal to 3. So the first step is we write first the equation of variation by translating this statement: a varies jointly as b and c. So technically we must have the mastery on how to write or translate verbal statements into mathematical equations. So we have here a varies jointly as b and c. So you have k, b, and c. So you have a is equal to kbc as your translation. So to find the equation of variation, first we have to find the value of k, or our constant. Okay. So in our translation, we just substitute the values of a, b, and c. So we have a, which is 24, is equal to k multiplied by 2 and 3. Since we are referring here to multiplication, since there is no operation indicated here, so automatically that will be multiplication. So we have 24 is equal to k times 2 times 3, so that will be 6k, and then divide both sides by 6. So k is equal to 4. So our constant here will be 4. So our equation will be, so you write here the equation. That will be a is equal to 4bc. So that is our equation. So whenever you already have the equation of variation, you can now find any unknown variable. So you just manipulate all the values to obtain the missing and the unknown, or the unknown variable. Let's say you have, let's have an example here for this particular equation. Let's say I want to find the value of a. Say find a when, so we have to state the values of other two quantities. Let's say you have b, find a when b is, let's say, 6, then c is equal to 8. Okay. So using the equation of variation, so we have A is equal to 4 our B multiplied by 6 our C multiplied by 8. So we have 4 times 6 times 8. So the value of A is equal to 192. So just the same thing, if the missing value are the other quantities, let's say B and C, you can actually manipulate the equation. So let us have the next example. So the area of a rectangle varies jointly as the length and width, and A is equal to 48 square centimeters when L is equal to 12 centimeters and W equals 2 centimeters. Find the area of the rectangle whose length is 15 centimeters and whose width is 3 centimeters. So as we all know that the area of the rectangle is actually length times the width. Since we are referring to a joint variation, we just add K here. So you have A is equal to KLW. So that is the translation of this statement. Now the next step is to find the value of K. So find the constant using the value of area, length, and the width here. Okay, so we have A, so that will be 48 is equal to K multiplied by the length multiplied by the width. So you have 48 is equal to K times 12 times 2, so that's 24 K. Then divide both sides of the equation by 24. So K here is equal to 2. So our equation will be A is equal to 2LW. Then next, let's find the area of the rectangle whose length is 15 and width is 3. So for number 3, we have A is equal to 2 times 15 times 3. So 2 times 15 is 30 times 3. So our area here will be 90 square centimeters. So that is the area of the rectangle. So since we are given here K, the constant is 2. So instead of just multiplying 15 by 3, we have to include 2 as our constant. So the answer is 90 square centimeters. So that is how to solve joint variations. So again, you have to apply, or you have to master on how to translate verbal statements to mathematical equations, and then solve for the value of K, then the equation, and then the missing variable. So wait for the part 2 of this type of variation. So the next type, or the last type of variation, is combined variations. Okay, so we are now the last type of variation, which is combined variation. It is denoted as Z varies directly as X and inversely as Y. In symbol, Zy over X is equal to K, or Z is equal to Kx over Y, where K is the constant of variation. So from the word combine, we are now combining the first two types of variation, which is directly and inversely. So direct and inverse variation. So in symbol, you can actually change any, or we can write or assign any letter of the alphabet as long as we know how to translate verbal to mathematical equations. So just like this statements, so let us try to have this first as our view, how to translate statements into mathematical equations. So we have t varies directly as a and inversely as b. So we have t varies directly as a and inversely as b. So that's the answer. So this one you have y varies directly as x and inversely as the square of z. Okay. So again, that's how we translate statements into mathematical equations. Let's have our first example here. So if z varies directly as x and inversely as y, and z equals 9 when x equals 6 and y equals 2, find z when x is equal to 8 and y is equal to 12. So z varies directly as x and inversely as y. So that is the equation. So we're going to substitute all the values here. So when z equals 9, when x is equal to 6, so you have 6k and y is equal to 2 over 2. So what we're going to do here is we're going to cross multiply whole number here, 9, in the denominator of 2 to obtain 18 is equal to 6k. So we're actually going to solve for k here. So k is equal to 3. So if k is equal to 3, going back to our translation, so that becomes z is equal to 3x over y. Okay, so this is the equation of variation. Then what we're going to do now is to solve for z. Find z when x is equal to 8 and y is equal to 12 using this equation here. So find z. So we have z is equal to 3 times 8 over 12. So we have z is equal to 24 over 12. So the value of z is equal to 2. That's the final answer. Next example. So we have if r varies directly as z, or as s rather, and inversely as the square of u, and r is equal to 2 when s equals 18 and u is equal to 2. Find r when u is equal to 3 and s equals 27. So translate again. So we have r varies directly as S and inversely as the square of U. So substitute now. So we have 2 for R when S is equal to 18. So we have 18K switch over, we have 2 squared since you have the square of U here. So the next thing we're going to do is to square first 2 here, then cross it with 2 on the other side. So we have 2 is equal to 18K over 4. And then we cross 2 and 4 here. So we have 2 times 4. So we have 8 is equal to 18K. And then divide both sides by 18. So our K here will be 8 over 18, or lowest term will be 4 over 9. So our equation will be R is equal to 4 over 9 S over U squared. So that is our equation. So I'm going to find now R when U is equal to 3 and S equals 27. So R will be 4 over 9 S, so that's 27 over U squared, so that is 3 squared. So you just simplify this equation. So we have R is equal to 4 over 9 multiplied by 27 over 3 squared will be 9. Here actually we can cancel on the numerator part, so we can multiply 27 by 4 then divide by 9, or we can cancel or reduce 9 and 27 to lowest term. Since 9 is the denominator here, then you have the whole number of 27 by dividing 9 and 27 by 9. So 9 here becomes 1, 27 here becomes 3. So 9 divided by 9 is 1, 27 divided by 9 is 3. And then we can now multiply 4 and 3 directly. This one, this one. So R is equal to 4 times 3, you have 12 over 9. Or lowest term here will be 4 over 3. So the value of R is 4 over 3. So that is how we use combined variation. So it is a combination of direct and inverse. Same process. So you translate the equation of variation, solve for the value of K, and then solve for the missing variable to obtain its variation. So that ends the types of variation. So we started from direct, inverse, and then ended up with joint and combined variation. So thank you very much. I hope you understood the lesson. You can always review these topics. You can actually go back again and again. You can comment your questions, comment down below. subscribe to our YouTube channel, Sir Jello. Thank you very much and have a good day.